Welcome everyone to this Studyclix Masterclass. We are live streaming directly to you this evening. Thanks so much for joining us. We're absolutely delighted to have you. We are on the button of 7 o'clock. So you're in the right place, you're here at the right time. We're off to a great start. So get comfy, settle in, grab a paper and a pen, something to take notes, as we have some very useful tips to share with you tonight. To get started, just to introduce myself, my name is Amanda. I work for Studyclix as a schools engagement manager, which means I work mostly with schools who have set up student access to Studyclix through the school. And if you're not already aware, and I'm hoping that's not the case, if you've never heard of Studyclix before tonight, just as a quick run through, Studyclix is a website that tries to make your exams a little bit easier, and by providing resources that are designed to improve your knowledge around a topic, but also your exam confidence and technique. We do this by providing categorized past, state and mock exam questions by topic, and then extra resources for those questions, like annotated sample answers, solution videos, digital flashcards, and topic-specific quizzes across the website. These are really useful for your big exams, like your junior cert and your Leaving Cert, but also for the class tests and in-house assessments that occur during the year. Setting up an account, if you don't have one already, is super easy. Just visit studyclix.ie and take it from there, follow the steps. The basic account is free, which gives you a taster of all of the features, and then you might like to avail of one of our paid plans. All info about that kind of stuff is on the website. And we're delighted to host this free masterclass this evening for any higher or ordinary level Leaving Cert Maths students. So if you're currently preparing for the junior cert, feel free to stick around, but you might feel a little lost during some parts. And if you're a fifth or a sixth year, or even just an eager TY, definitely stick around. We're running this session especially for you. I'm buzzing to have Stephen Begley here with me this evening to share his 10 ways to get better at Leaving Cert Maths. Stephen is a face and a voice that you may already be familiar with through your use of Studyclix, as he's worked with us for a few years on the likes of solution videos and Maths Boost. He's a state examiner and a fantastic teacher. Honestly, I wish he was my teacher. If he was, I would have done way better in maths, honestly. So while it's a little bit too late for me at this point, it's certainly not too late for you to take on the advice he has for you. Just to say before I hand over to Stephen, this is being recorded and will be available for you to watch back at any time. We've just published an article as well on this topic, which you can check out on Studyclix, and you'll find it on the maths page. Feel free to pop any questions you have into the chat, and we'll leave time at the end to answer some of them, which is when you'll hear from me again. Thanks again for tuning in and joining us. I'll hand you over to Stephen now.
Thank you very much, Amanda, and hello to you all watching this evening. I just want to commend you first of all and say fair play on taking the first steps in trying to gear yourself up for your study for Leaving Cert Maths. And before we dive into, I suppose, my 10 steps in order to succeed here at Leaving Cert Maths, I think it's important to recognize, first of all, the different levels of success we're looking for here. I know I've higher level students on board here looking for a H1 or a H2, but I'm also conscious that I've got students just looking for that H6 to get their 25 points. But that's not to forget, though, as well, the students at ordinary level who might be pushing for that top grade, the O1 or the O2, or those who find it tough and are looking for that bit of support. As we go through these 10 things, each of these things are aimed to help you in some way, shape, or form. Some will help certain students more than others, but I think it's really valuable to take note as we go along of some of the key points as we go. And without further ado, we're just going to dive into our very first item around what does studying maths look like. Now, look, this is a tale as old as time question. We hear it from the first years coming in the door right through to the sixth years going out. They simply say, I don't know how to study maths, so they just stay away from it. This is the simple formula, and it's very straightforward. Doing questions is studying maths. There's nothing else to it. You need to sit and do good questions. Now, what do I mean by good questions? I'm not talking about all the easy questions at the start of a topic or, at the beginning of the exam papers, the part A's or the part 1s. I'm talking about doing medium to tough questions in your revision so that when you come to your exam, you have experienced challenge and you have experienced tougher style questions. So what type of questions where are you going to find these questions? Your main resources are your textbooks, your revision questions at the end of each chapter. Your past tests are so important because they tell you what you know and what you don't. So you need to have a look at those questions that you don't know how to do and get them figured out. And I'll talk about how we figure that out later on. We have our lovely Studyclix quizzes that were made with exam style in mind. And finally, your exam paper questions. So each of us have ample access to questions on either Studyclix or with our own resources in our textbooks. So this studying maths, this doing questions, what do I want you doing from here on in? You just have to get started. You're not going to walk down the road on Wednesday, tomorrow afternoon, after school at 3:30 and say, do you know what? This is the moment now that I'm going to study maths. Those moments don't happen. You just need to be, I'm going to be blunt and honest and say, you just have to sit down and get started. So what does this getting started look like? First things first, make a list of all the topics you've covered. So if you're in 5th year or 6th year, that list will be different. Rank them from worst to best. So which ones have you scored the worst on in your tests? Which ones have you scored on the best? Now it's so obvious that we'd always jump to the tests we've done best on and revise that topic first. That's not the case. Start with the worst. It's not an easy thing to do, but you just have to start there because it'll make the other ones as you progress easier. As the year goes on, you want to have started with the hardest ones so that as things get busier come January, February, and even May next year, you're on to those easier topics as we go. You're looking at trying to cover a topic in 1 to 2 weeks. That's a reasonable period of time for any standalone chapter. So what does this doing maths or sitting doing questions look like? You just need to get 2 small sessions done a week. I'm talking 20 to 30 minutes where you sit down and solely focus on your maths. So let's say, for example, you're working on trigonometry. You want to have your first revision session early in the week, 20 to 30 minutes. Set a timer. It's so encouraging after you set your timer and you look back at the end of your session and you can see the evidence of your revision and you can see what you've achieved in that time. Or that timer might tell you you need a bit more time on this topic because you haven't progressed much through it with that time. So I'm looking at throughout the year, constantly weekly, 2 small revision sessions. Then depending on where you are and trying to push for that grade, or if you're on a busier topic, you need to get 1 big session in as well of 40 to 60 minutes. So if you achieve those, you're on balance talking an hour 40 and to 2 hours of maths a week. That's the revision that will help you succeed. And I'm going to be blunt again, and I'm not going to be blunt too much throughout the rest of this. You just have to start. There is no magic moment that's going to kick into your life to say, yes, here it is. This is the moment I'm studying maths. Get started. So after today, get your time, get me a 20 to 30 minute session started on your first topic. I've mentioned already where you're getting questions from, and I think we can get into resource overload at time. There's so much out there. But the basics, your textbook, your past tests, the Studyclix quizzes, the Studyclix boost, and your exam paper questions is more than enough for you to succeed at any level here. I suppose one thing I'd always say, I'd always hear after hearing the phrase, I don't know how to study maths, is I don't know what the question is asking me to do. And that's a very fair thing for someone who hasn't practiced, okay? So what I want you doing is when you're working systematically through your vision, say you work on algebra cubics and you do all the exam paper questions related to that, you're going to see the style of wording and the style of questioning that comes up for that topic. And it's in practicing those questions, it's in doing the questions that you get used to the wording. You're not going to know it off the bat straight away. And sometimes if you're thrown that you don't even know where to start with the very first question, that's what we'll talk about next in step number 2. But first and foremost, step 1, you need to leave here today knowing that studying maths is doing questions. It's not reading notes. It's not listening to podcasts for maths. It's sitting doing questions. There's times you'll reference your notes. There's times you'll pop on to Studyclix Boost and watch a video, but ultimately you have to sit down and hammer through questions. Now, in hammering through those questions, you're going to struggle. And I'm saying here, the struggle is real and it's really valuable. You're inevitably going to get stuck. We always do. Every mathematician has. You're going to reach a point where you can't move on. And that might be at the very beginning of the revision, or that could be midway through a session, or it could be at the end. But it's first things first is that's going to happen. Secondly, is the important thing is what you do to help yourself from here. If you get stuck, you can leave it and just park it. But what I want you to do is I want you to get stuck. I want you to seek help. And we'll talk about where you can seek that help. Seeking help will hopefully help you figure it out. And in doing that process, get stuck, seek help, figure it out. That is learning maths. That is maths in action. You are doing questions through that whole process and even asking questions as well. So that is constantly what's going to happen here. We have to get used to the struggle. Maths is hard at ordinary level, at higher level, and even foundation level. So we have to persevere. We can't get bogged down the moment we're stuck. You have to seek help. Now, where can you get help? First thing I'd be doing is in that revision session, say it's tomorrow evening you're starting, I'd be checking my notes. If I can't find something in my notes, I'm looking to my textbook. You could send a message to a friend, or you could get a study group together, and you can also flag it and ask your teacher. There's nothing better than, as a maths teacher, that you have students coming up to you at the end of class with a question they've been working on in the revision, and you can point them in the right direction. Your teachers are the best resources to you. They're your main point of call. So link in with those. But the one place you can find help as well is with Studyclix Boost. Now, I know some of you here might be familiar with it. However, for those who are not, I'm just going to jump over to the Studyclix website here. And if I go into maths, I'm going to pick one of the topics that I might be struggling with. So let's say, for example, algebra cubics I'm finding tough. So most of us know this page where we find the related exam paper questions, but here beside the questions in the tab, we have Boost. This is where Boost lives. And Boost is a platform that breaks the entire course down into 3 to 5 minute bite-sized videos, followed by some practice questions and quizzes to support your learning on any topic at all at ordinary level maths and at Leaving Cert and at higher level maths. So say I'm in here and I'm looking at the algebra cubics topic. Along the right here, you can see I've got a tutorial followed by a test yourself section for everything related to algebra cubics. So let's just pick a video here. Say I pick the factor theorem and it's a proof using x plus k. You'll see here I've got a 4 minute and 51 second video of myself or my colleague Alan working through these videos. So you can see here we've got a sample exam style question, followed by a bit of a discussion, breaking the question down, highlighting keywords, trying to get the understanding around what the question is asking us to do. We do a full walkthrough and explanation of everything that happens to get the question done, and a few kind of exam tips as well for you to figure it out. Now, while you're using Boost, the effective way is to sit and do the question with me. Pause the video at the start, scribble down the question, and work through the solution with me. Maths is not a spectator activity. You can't just sit and watch. It doesn't sink in. We need to be doing it. And the lovely thing about Boost, after our tutorial video, we have our test yourself section. So straight after that, I have 3 exam style questions here for me to check in on my knowledge on that topic. So if you're focusing, say, your revision on algebra cubics, this is a very good place to focus your revision around, because 1, you get the explanation immediately, and 2, you get the practice exam style questions that we created. Underneath the questions, we have a detailed explanation on everything you need to achieve in that question. And as I say, if I go back to my maths menu here, we have this for every single topic at Leaving Cert ordinary level and at Leaving Cert higher level. Now, Maths Boost is an extra add-on, and it's $74.99 for a year subscription to everything you need in Boost. So for the price of what? 1.5 good grinds, you have access to a year's worth of grinds instantly at any time at a space and at a level that suits you. And the beauty is you can rewatch the videos, or you can link the video perhaps to our community and just ask a question based on that. So if I jump back over here, I'm saying the struggle is real. Yes, it is. We are going to face stumbling blocks all the time, but you need to seek the help. And I hope you can see that Studyclix Boost is a space willing to help you at any time or at any space. So that's kind of the blunt side of it over, okay, explaining how to study by doing questions and that we are going to struggle and we need to push through. But if I move along now onto some practical elements, as an examiner and as a maths teacher, I always see some very, very common mistakes. And algebra is the space where these will happen at ordinary level and at higher level. And I think you often know yourself if you've made this mistake, because you might get an equation with some mad-looking numbers, or the question might have asked for something in third form and you get a whole number. So you've slipped and you've lost something along the way. And I know it's really difficult to check your work. As a mathematician myself, I find it so hard to say, oh, I'm going to go back and check over everything I've done. But if you have made that mistake, check over and keep an eye for some of these very, very mistakes that I'm going to show you what they are and what they aren't. So if I jump over to my tablet here, the first mistake I saw it today in class alone with 2 students in 2 different groups, the sneaky double minus. So when we're simplifying this, 3x minus in brackets 2x minus 5, some people often think that there's a -1 multiplying into that bracket. So what I need you doing is saying we keep our 3x, we multiply the -1 by the 2x to give me -2x, and I multiply the -1 by the -5 to give me a +5. That's the mistake I always see. Some people say it's -5. So that's naturally going to skew the rest of your solution working down with that. And when we simplify this, we get x plus 5. So I want you being very careful with that double minus. So if your solution isn't working out for you, jump back and say, was there a double minus missed anywhere? So that's the first. Next up is the silly mistake made in squaring. So if I have a look here at x plus 4 all to be squared, I see the best of mathematicians turning around and saying, Stephen, that's x squared plus 16. You square the x, it's x squared. You square the 4, it's 16. That is absolutely not the case, okay? And that's what makes us lose our marks in our quadratics. It loses our marks in our simultaneous equations. Anything with lots of expressions, you need to be careful. So let me show you the 2 kind of common ways I see students do this. And I want to show you kind of a bit of a shortcut or a trick that I often use to deal with our squaring. So I know in terms of the first way, if we have a look at way 1, squaring means to multiply something by itself. So x plus 4 squared would mean take x plus 4 and multiply it by itself. And I know a lot of you would come along with your arrows and do x by x, which is x squared, x times 4, which is 4x, 4 by x, which is 4x, and 4 times 4, which is 16. And you tidy up the middle there to give me x squared plus 8x plus 16, which is the correct answer. So you can see in the incorrect one that I crossed out, we wouldn't have had the plus 8x. So that's one way people would do it. Another way that has become quite popular lately, and some students would use it maybe to start off and to build themselves up into working with quadratics, is using the lovely little array or area model where we have our x and our plus 4 on the side and our x and our plus 4 on the bottom, and you're thinking, okay, let's get the area of each square here. So where this first little red x is, I'd be multiplying x times x to give me x squared. I'd be doing x times 4 to give me 4x over here. On the bottom, we'd be multiplying 4 by x to give me 4x, and 4 times 4, which is 16. And then when we come to tidy this up, I'd be getting x squared plus 8x plus 16, the exact same answer in the first way. So look, they're the ways that I know you're familiar with, but I want to show you a quicker way to deal with squaring, seeing as we do it all the time. So if I take my x plus 4 and I want to square it, the 3 things I'm going to say here are: first, square the first term; second, square the last term; and third, double the first by the last. So what do I mean by this? Square the first term. The first term in that bracket is x, so square it. I get x squared. Square the last term. So the last term is 4. 4 squared is 16. And I have to double the first by the last. So when I double the x, I get 2x. And 2x by the last term, 4. 2x by 4 is 8x. There we have it. x squared plus 8x plus 16. And I want to show you this for a few more. So what if we had y minus 3 all to be squared? Well, let's go through it. Let's square the first term, square the y to give me y squared. Square the last, so I'm squaring minus 3. So minus 3 times itself, minus 3 times minus 3 is plus 9. And I want to double the first by the last. So double the y to give me 2y, and 2y by the minus 3y is minus 6y. And if we have a look at one more scenario here, if I have 3x plus 1 all squared, I go ahead and I square the first term. So 3x squared, square the number, square the letter, gives me 9x all squared. Square the 1 at the end. 1 squared, 1 times 1 is 1. And I double the first, so double the 3x to give me 6x, and 6x by the 1 gives me 6x. So take your pick, whatever way you do it. I simply don't mind, so long as you don't tell me that the answer to that original question is x squared plus 16. So once more, the wee shortcut is square the first, square the last, double the first by the last. Other mistakes we see here come into play when we fractions. Sometimes these just naturally come up in certain equations. So if we have a look at our first one, our 3x minus 2 all to be squared, which is, 3x minus 2 over 5x all to be squared. Now, how do we square a fraction? We have to square the top and square the bottom. Okay, so I'm going to square that top line by using my rule. Square the first, square the last, double the first by the last. So when I square the 3x squared is 9x squared. Square the last, square the 2 to give me 4. So minus 2 squared is plus 4. And I double the first by the last. So double 3x is 6x. 6x by minus 2 is minus 12x. So we've squared the top. I often see that folk would forget to square the bottom here. So if I square 5x, square the 5, 25, square the x, x squared. That's how we square a fraction. So top line following our rule, square the first, square the last, double the first by the last, all over the bottom squared. And lastly, this one's maybe more so for the higher level folk. Let's do some uncomplicated cubing here. We know squaring means times something by itself twice, and so cubing means multiply it by itself 3 times. Now, as an examiner, I always see some very creative ways as to how people would go ahead and cube a bracket. But the reality is we can only do 2 brackets at a time here. So I'm not going to show you all the versions, but I hope you'll agree with me that multiplying a bracket by itself means squaring it. So I could write those last 2 brackets as x plus 2 squared, and I'll keep the original x plus 2 in front. So what I'm going to do now is do x plus 2 times x plus 2 squared. So if I keep the x plus 2 in front, I now know how to quickly square a bracket. I square the first, x squared, square the last, 2 squared is 4. Double the first by the last, so double x, is 2x, and 2x by 2 is 4x. And all we're going to do now is fire in the x to all 3 terms, and then fire in the 2 to all 3 terms. So when I multiply x into all the terms, I get x cubed plus 4x squared plus 4x. And then we're coming along multiplying 2 into our pink bracket to give me 2x squared plus 8x plus 8. And now what we can do is add together our like terms. Our x cubed is out there on its own. If I add together the 4x squared and the 2x squared, it gives me 6x squared. And then I'm going 4x plus 8x, which is 12x. And then I have my plus 5 at the end. So if you're in your exam, Christmas exams are coming up, mocks are coming up in January for the 6th years, and the real exams June this next year or June 2027, you need to stand back and say to yourself, right, if I've made a mistake in my algebra, have I made a mistake with the double minus? Have I made a mistake squaring? Have I made a mistake cubing? Or have I made a mistake with my fractions? It's very hard to check our work, but keep an eye out for those things for me. Right. They're the common mistakes I would see in algebra. Moving on to section 4, this is a lovely wee list. It is the things that you need to know about your calculator. Okay, you should not be going into an exam for the first time figuring something out on your calculator. If you're a serious student, which I know we are because we're all here this evening, you have to have this sussed beforehand. A good half an hour gets all of this figured out. Now, if you're in 5th year, you may not have met some of these things, or in 6th year, you still mightn't have done some of these chapters. But on the blog post for the back of this article, the back of this webinar, we have this list here. So you make this list, check it out that you can cross everything off. Can you do the mean on your calculator for your statistics? Can you find the lower and upper quartiles? Can you calculate standard deviation, correlation, and find the equation of best fit? There's loads of different calculators in play. Your teachers are there to help you. Online on YouTube, all the calculator brands typically have videos going through everything, so get it sussed out. For our functions, can you use the table mode to get the points on a graph? For probability, can you find the factorial button or our combinations button? And other little things like the degrees, minutes, seconds button. Or for those at higher level, there are some calculators that can express a number in polar form, and that's good to check your answer in a complex numbers question. So there's not too much more to say here other than before your Leaving Cert exam, you need to sit down and say, can I do all of these things with my calculator? There's lovely, easy marks up for grabs, both at ordinary level and higher level for these types of things, particularly in statistics. In a similar sense to the calculator, we need to know our log tables. If you are studying maths at any level, you need to be sat in your class while you're doing your chapter with the log tables open. You need to see who is in the log tables while you're learning the topics, okay? Because that also highlights what is not in the log tables. There's a sizable number of formulas not in the tables book, so you need to have them sussed. And if you've done the following chapters that we go through, you should be working to memorize these formulas. I kind of think back to my time in college, particularly when I had to learn a hell of a lot of formulas, or even for Leaving Cert. It's not easy. It's rote learning. It's not pleasant. And there could be up to 30 formulas that you need to memorize if you're doing maths and physics, say. So you need to find time early on to get them learned off. So in fifth year, if you've come across any of these topics, get these drilled into your head now. If you're in sixth year and you're working on your study and you've covered these topics already, you need to find the time to figure them out. You might have to sit and write each formula out 20 times. And if that's what it takes, do it. I know myself, I would have at times made up little rhymes or little stories or used people's names, Alan and Bob or whatever it might be, to create a story around the formula. If that's what it takes as well, do that, but just make sure you know your story. So again, we're going to share this up on our blog. All these formulas for both higher level and ordinary level will be available for you to look back on. So here you can see the plethora of probability formulas at higher level. Statistics is the big one. And I always hear students say, oh, but there's bits of it in the log tables, there's parts of it. Yes, there are small pieces of the confidence interval formulas in the log tables, but they're given names that mightn't say confidence interval. They might be called standard error or things like that. So just get them learned off. Statistics is the big one because you can't really enter the statistics questions at ordinary level or at higher level when they're talking about empirical rule or hypothesis testing if you don't have the formulas. So get them sussed, get them learned off. And for formulas like these, the ones that aren't in the tables, you will get some marks for writing them down in a relevant question. And I suppose this brings along the angle of, what about the formulas that are in the tables? So let's just say you are doing the area of a circle question and you write down the wrong formula. You're getting no marks simply because the examiner is saying, well, I've given them the log tables with the formula and they've written it down wrong. So you won't get any marks for just writing a formula that's in the tables. You might get some marks for writing down the correct radius of that circle or something like that. But the examiner often isn't generous if a formula is written down wrong that is in the tables. However, for the ones that aren't in the log tables, like these ones, you may get some low partial credit for simply just writing down the correct relevant formula. You get even more for subbing some numbers in. Moving along here, there's some common formulas now for higher and ordinary level that aren't in the tables, say for sequences and series, for area and volume. Now, looking at the higher level, and I suppose when I put this up into the blog, I was saying to myself, are these more methods or are they formulas? For the sum of two cubes and the difference of two cubes, I suppose they are a formula or an identity, but the discriminant down below is perhaps more of a method. And I know, say, for calculus and differentiation, there's a lot of methods. We haven't included those here simply because they're not necessarily a formula, they're more of an approach of how to do something. In the maths world, I'll not bore you with it. There is some, I suppose, controversy over whether the sum of two cubes and the difference of two cubes needs to be learned off. Technically speaking, if the examiner was to ask you a question on it, they would provide those formulas. How and ever, there's often times that the sum of two cubes and difference of two cubes can be used to advantage you in a question. So I'd just simply get them learned off. Last couple of formulas here, we have our trigonometric functions for Leaving Cert higher level, and I have the ordinary level probability formulas here too. Moving on then, when we are studying maths, so we're going through this motion of we're going to be doing questions and we're going to be struggling at times and we're going to seek help. When you seek help, for example, you might pop onto Boost and I will show you how to do something in a totally different way than your teacher does it. And then you might jump to one of our solution videos and you'll see, okay, well, they've worked with the marking scheme and seen another way of doing something. It's really good and healthy in your maths revision to see things from another perspective. There is simply not one way to get an answer to any question. Think of the different ways you can add to make 5. There's infinitely many, 2 and 3, 1 and 4. Then you go into your decimals. All of them achieve the same correct answer. So I think it's really nice for you, if you're in a position that you've mastered a topic, to go and explore some other ways of doing it. Algebra is very much the realm that this can happen in, but same with problem solving questions around areas or trigonometry is nice too. So what I want to do is show you these two questions, and it was students who had shown me over the years the different styles and ways they'd have approached them. So there's the ways I, as a teacher, from learning the methods and strategies over the years that I'd employ, but then being creative and thinking outside the box got these figured out in a different way. So if we jump over and practice a few of these, so if you're in higher level, you would have probably seen most of this by now. Those at ordinary level may not have, but it's good to see how other methods can work. So we're told here to express 4x squared plus 16x plus 12 in the form a times x plus b squared plus c. Now, some of you might recognize this as complete square form. This is also called vertex form, and there's some steps that you might need to know to figure this out. And I know in my Studyclix Boost video, I go through this way. First things first, we need to factor out the coefficient of x squared. So we're going to factor out 4. And we're going 4 into 4x squared to give me x squared, 4 into 16x to give me 4x, and 4 into 12 to give me plus 3. And the steps for completing the squares are as follows. We halve the coefficient of x, we square it, we add and subtract it in. So first things first here, we have the number in front of x. So I halve 4, which is 2. I square this number. 2 squared is 4, and then I add and subtract in this number 4. So where do I do this adding and subtracting? Right here, okay? So let's rewrite our expression. I'm going to get 4 times x squared plus 4x plus 4 minus 4 and plus 3. So we're following our steps. And don't stress if you've not covered complete square form yet, or you've not gotten to it in your revision. You will. Right, what's next here? Well, the first 3 terms inside this bracket are a perfect square quadratic. And if I actually think about my squaring from earlier, square the first, square the last, double the first by the last, that comes into play here. Because what squared gives me x squared? Well, it's x. And what squared gives me the 4 at the end? Well, that's plus 2. And if we square that out, you get that quadratic. So we're going to say that that yellow part is x plus 2 squared. Now, let me keep all the rest of my numbers. I have a 4 in front. I have a big green bracket. And at the end, I've got minus 4 plus 3. So minus 4 plus 3 is minus 1. So I'm going to stick a minus 1 here at the end and close my bracket. Looking up at the form, I need to multiply that 4 into the brackets. So 4 multiplied by the x plus 2 squared is 4 times x plus 2 to be squared. And we multiply the 4 by the minus 1 to give me minus 4. And there we have our answer in the form a times x plus b squared plus c. We have completed the square for this quadratic. Now, let's say it's the Christmas exams, it's the mocks, or it's June 2026 or 2027, and you're saying, I remember Stephen banging on here about steps for complete square form. To hell, I cannot remember them. Let's have a look at another way. And way 2 here is really nice because you don't need to remember any steps whatsoever. So let me show you what we do. We take the 4x squared plus 16x plus 12, and I'm saying, right, they want me to make this look like this. A times x plus b squared plus c. I'll write a nicer squared there, s squared plus c. Right, well, this is now an equation, and what I'm going to do, sorry, apologies, I'll actually just write this a bit neater. There's no use me showing you if we can't read it. So we're going a times x plus b to b squared plus c. Now, I have an equation here, and I want to balance both sides of it. So let's see what we're going to do. Let's zoom into this. What I'm going to do is expand and multiply out the right-hand side. I'm going to keep the a out front. I'm going to square that bracket. How do I square a bracket? Square the first, square the last, double the first by the last. So I square the x to give me x squared. I square the b to give me b squared, and I double the first by the last. So 2 by x is 2x, 2x by b is 2bx. And then I have a plus c coming here at the end. Last thing I'll do is multiply the a in. So I get ax squared plus 2abx plus ab squared plus c. And I know this all has to equal that same left-hand side of 4x squared plus 16x plus 12. Now, we've not done any steps, we've just let them equal and we've multiplied it out. We're going to equate the coefficients of the x squareds, the x's, and the constants. So on the left-hand side, I hope you'll agree there's a 4 in front of the x squared, and that has to equal the coefficient of x squared on the right, because these things are in balance. So that has to equal the number in front of the x squared, which is a. So you can see there I've gotten a equals 4. Let's move on to the x terms, okay? So if I think about the 16 in front of the x on the left, that has to equal the number in front of the x on the right, which is 2ab. Now I'm saying to myself, Stephen, you know a is 4, so fire that in, 2 by 4b, and I'm getting 16 is equal to 8b, divide both sides by 8, 16 divided by 8 is 2, so I'm getting here that b is equal to 2. And then finally, I'll think about the constants and say a constant has no x, so on the left-hand side, that's the 12, and the things without the x on the right are ab squared plus c. Now, we know a and we know b, so let's fire these numbers in. A is 4 and b is 2. That has to be squared, and that gives me c. And I get 12 equals 4 by 2 squared is 16 plus c. Now, if we want to isolate c on its own here, we'll subtract 16 from both sides to give me minus 4 equals c. So why did I find these numbers? Well, I'm going to go back up here to my complete square form and fill in what a, b, and c are. So a is 4, so I get 4 times x plus b squared, x plus 2 squared, and then I have a plus c, so it's plus minus 4, so we're just going with our minus 4. And if we have done this right, which we absolutely have, I go back over to my first way of doing it and see that we got the exact same answer. So look out for these in your revision, particularly if you're crunching for that top grade. You're going to have to problem solve in the exam in ways you've never seen before. So the best way to prepare for that is to keep ourselves open to these niche wee ideas. We'll take a look at one more way, and it's a little bit quicker than our last one. We're asked to simplify the following. I've x cubed minus 8 over x minus 2 squared. Now, those who recognize the top line here as a difference of 2 cubes, fair play, because it is. X cubed minus 8 is the same as x cubed minus 2 cubed. And back to the formulas I'm telling you we need to remember. If I have x cubed minus x cubed minus y cubed, it's equal to x minus y times x squared plus xy plus y squared. Okay, so x in this case for me is x, and y in this case is going to be the 2 because that's 2 cubed. So let's fire this into our formula to give me x minus y, x minus 2 multiplied by x squared, which is x squared plus xy. So 2 by x gives me 2x, and plus y squared. The y here is 2, so 2 squared is 4. So hopefully you can see that I've filled in for x and y here. And that's the factorized version of that. Now what they want me to do is to take that x minus 2 times x squared plus 2x plus 4. And in the question, they want us to divide that by x minus 2, right? You can see there on the top line, we have a factor of x minus 2. On the bottom, I have a factor of x minus 2. Factor divided by itself gives me 1. So the answer to this question here is x squared plus 2x plus 4. Now, this way of doing it, and again, if you haven't revised it, that's fine so far. If this way of doing it requires memorizing that formula for the difference of 2 cubes, I want to show you another way that we can work this out without any formula, without any memorizing. So let me just get rid of that for the moment. And let's think about the question again. They want me to take x cubed minus 8 and divide it by x minus 2. That's another way of thinking about this question. And how do I do division? Well, I think about this big division symbol. I'm taking my x minus 2 and I need to divide it into that. Now, typically when we have a cubic, we have an x squared term, we have an x term, and we have a constant when we normally see these set up. So let's have a look at this here in the format we'd normally see it. Now you can see what I've done there. I've added in a 0x squared because there is none, and I've added in a 0x because there is none, and I wanted to just have the format so I can long divide. And we're just going to do our long division, and at higher level particularly, that's a skill we have at the back of our hand. So we go x into x cubed leaves me with x squared on top. I take this x squared and multiply it back, so I get x cubed minus 2x squared. You can see where I've written that. Step 2 is we change our signs on the bottom, minus and a plus. I always circle my signs when I change them. Then I know I have done it. We remove our x cubes, there's 0. Then I've got 0x squared plus 2x squared, which is 2x squared, and the rest all comes on down. We go again now, first into first, x into 2x squared gives me 2x. So on top, I'm given a 2x here. Multiply back with our 2x. So I'm getting 2x by x, which is 2x squared, and 2x by minus 2, which is minus 4x. On that bottom line, I'm changing the signs. You can see here I'm circling them so I know they're changed. And then we're adding together. We've 2x squared minus 2x squared, which is 0. 0x plus 4x gives me 4x, and I have minus 8 at the end. And we go again, first into first, x into 4x gives me 4 on top. I take the 4 and multiply it back to give me 4x minus 8. And finally, I'm changing the signs. I have a minus and a plus. I'm circling them so I know I've done it. And I get a remainder of 0 at the end. And you can see here on the top, we got the same answer as our difference of 2 cubes. We got x squared plus 2x plus 4. And if I go down here towards the end, you can see, do a wee zoom here, we have the exact same. Apologies, that's us there. So x squared plus 2x plus 4 for both ways. So main message from all of that, everyone, is to stand back and take a look at other approaches. Yes, we do need to learn the formulas at times. Yes, we'll have to use them, but also just see, can we get creative with figuring things out? Next up, we're going to take a look at how we approach busy exam style questions. So what I want you doing is saying to yourself, right, stand back. If we can't figure something out, say, have I used all the information given to me? I know it's a very obvious statement in a question. Of course, you're going to try to use the information given to you, but you might miss something as we go along here. So let me show you kind of what I'd be thinking in terms of highlighting important information in a question and talk about the layout and presentation of these. So let's jump over to some sample questions here. So this is a higher level one, 2025 paper 2 question 1C. I'm not doing out a solution video. We have all that there, and you may not have even done this topic. Now, what I don't want to see is you sat in the exam saying, okay, I'm highlighting. Stephen from Studyclix said highlight, so let me highlight everything and we'll fire a rainbow across our page. No, that's no good to you because you've not highlighted what's important. So I'd be saying to myself, okay, the first line there, a line cuts the x-axis at the point A0. So I'm saying we cut the x-axis, that's important. The next point I'm saying I cut the y-axis at the point B0B. So I'm focused and saying, okay, I know what this looks like. I'm on the x-axis, I'm on the y-axis. I could perhaps draw a picture from this information. Next up, we're told the slope of this line is minus 2/3. Now, they're not telling you that piece of information for the crack because it's unnecessary. They want you to do something with it. So you need to stand and say, slope is minus 2/3. I'd be extracting that down here and I'd be saying to myself, right, how do I use this fact? Well, I know, there's a slope formula, so let me maybe get that set up, saying y2 minus y1 over x2 minus x1 has to equal minus 2/3. I'm actively using the information given to me. Then they go on to tell me that the area of the triangle enclosed by this line, the x-axis and the y-axis, is 12 square units. I'm not going to highlight everything. I'm going to say the area of the triangle, and I feel saying that it's a triangle is important because that's going to guide our formula. I'm thinking of all the different formulas, half the base times the height, half AB sine C, and our coordinate geometry formula. And I know that this is 12. So I'd be saying to myself, right, how do I use that? Well, I'd be saying that the area of the triangle is equal to 12. And I'd need to then think, what formula might I use? Now, if we draw the line, and if we go back to that beginning of knowing where we cut the x-axis at the point A and the y-axis at the point B, this triangle is going to fall in here. And because of that, we might use half the base times the height, or you could use your coordinate geometry area formula. You have a few different ways to do it, but I'd be linking my formula is equal to the value given, and I'm going from there. So you can see I'm not highlighting everything. I'm saying what's the method or what's the buzzword in the question they want me to get at. And then finally, we'll take a look at the last bit. We're told that there are two different lines that satisfy these conditions. Find the equation of these lines. So what I want here are the equations of these lines, and I'd be extracting that out and I'd be saying, right, Stephen, what do I need to find the equation of a line? I need a point and I need a slope. And then I'd be thinking, right, how am I going to find those things? Well, all of this information back here is going to help me along my way. So as I say, I'm not going through this question. I just want you to show you how you can effectively highlight important things. Don't highlight it all. You'll lose the question when you do that, okay? We want the key maths moments, key numbers, key formulas. Thinking about this at ordinary level as well, this approach applies. Here, last year, paper 2, 6B, we saw Owen writes down 5 positive whole numbers from smallest to largest. The median of these is 9, mode is 6, so on and so forth. We want to find the 5 numbers that Owen writes down. So I'd be saying to myself, right, I need 5 numbers. That's a pretty important thing. So I might be saying by the end of this, I need to have a list where I have number 1, number 2, number 3, number 4, and number 5. Then what's the important information given to me? I'd be saying the median is 9. So I'd be taking that down here and I'd be saying, right, Stephen, the median is 9. What the hell does that mean? Well, the median's the middle. So I know that the middle number in this list is 9. So I could maybe lob 9 into the middle of my list. I'd be standing and saying, right, next up, mode is 6. Take the information out. Mode equals 6. And I'd be saying, what does that mean? Can I show the examiner I understand what mode means? Mode is the most frequent or the most popular. And I know that I need a popular number here to be 6. I need multiple 6s. So I won't go through the remainder of it, but I hope you can see what I mean by highlight the important information. Pull that into your answer box and get doing something with it. Show the examiner, narrate to the examiner in a quick fashion what you're doing. I'm taking this information that the median is 9. I'm working something out. I'm taking the information that the mode is 6. I'm working on from that. And in the same sense with the higher level, you have shown the examiner here, you've extracted the information of the slope, you've tried to use it. You're extracting the information of the area, you're trying to use it, and you're going from there. Just while I'm in this space, let's just say you're working on a very, very long question and you have a solution all worked out and your answer box looks like this and you have your solution here on the left and you're saying, I think I've slipped. I'm unsure if that's the correct way to have done this. I think I have another way. What I'll ask you to do, don't tip exit. Tip X and maths don't combine well. Just do a very clear line through it. One single one is fine. You can do a big X if you want, but make sure the examiner can still read that, because if there's something right that you're going to get more marks on there than in your other solution that you will present beside it, they may give you the marks. They mightn't always be able to, but they may, if you have another solution there, say, that one warrants some more marks. While I'm in this space as well, and I'm thinking about the layout of questions, I see in every exam I do, pretend this is the answer box with all your little grid lines in it. Everyone dives straight in and writes really big in the middle. You don't have the space if you make a mistake and need some more space or need a bit of paper to work things out and be writing in the middle. Start here, top left corner, please and thank you. I'll let you skip a wee box over. Start writing there, okay? And work down the way, okay? If you're working sideways, show that, do a wee arrow, okay? Because most of the time, as we know in maths, we'll work down the way so that it's followable for the examiner. And also just feel free to split your page up if you feel you're going to be able to work down the way, but start on that top left. You don't want to take up all the space in the box and then say, goodness, I've made a slip and I need to flick to the back of the page, the booklet, and start doing answers there. That adds stress that we simply do not need. And I know a lot of people might present their answer like ANS, x equals 4 at the end of something. Some people might underline it or put a wee box. It's nice to get into that routine. Does it get you marks? No, but this is what the examiner will do. The examiner will first check and say, right, did they get this part right? Yes or no? If they have, they'll scan the work above and all will be good. However, if they got it wrong, we now know we're just slowly working back up the way through the organized work there. So presentation, or as we call it in maths, exposition, doesn't get you marks, but the examiner will really like it. But in terms of the layout there, top left corner, please and thanks for the layout of our answers. Moving along here now to section number 8. Now, this is one that some people will run from and some people will dive on into. And I'll answer this question that we often see through the community on Studyclix, and that is, can I leave out a topic? Right. If you're aiming for a top grade at ordinary level or at higher level, the answer is simply no. We know what exam style questions look like. Them application questions in section B mix together any topics they want. We can see probability, trigonometry, area, algebra, statistics, all mushed in to one small space. So you can't really leave out a topic there if you're looking for that top grade to leave out. However, some people I know might stand back and say, I'm just trying to get my H6 here. While I don't advise leaving anything out, you might look at our step 10 here in our masterclass as to some of the topics that come up in a lesser capacity, and I might suggest that, but my rule of thumb is we need to cover it all. Now, one topic that people will often leave out when I do hear they leave something out is the geometry, just given that we do have our optional question due to the amendments on the exam, and geometry sometimes can be either way too hard, but on the flip as well, it can be really, really easy, and it's an easy grab of marks if we know what we're doing. That's, I suppose, at higher level. At ordinary level, geometry is a must. We need to have it, and you only have the constructions to worry about. You don't have the proofs, so it's really handy at ordinary level to get our heads around this. Right, most teachers may leave geometry till the end of the course, but when you have a bit of quiet time, after these exams, the foot's going to be off the pedal after the November exams or after our Christmas exams. Find a couple hours. Get geometry construction sorted. We have our Studyclix videos on our boost there for all the constructions, and we have our exam solutions for all the proofs. So get them learned off. They are really easily learned off. You just need to practice, repeat, practice, repeat. If you aren't planning on covering them, okay, so if you are covering them, you simply just have to learn them. But if you're not, cover yourself. This is how you can cover yourself. For the constructions at ordinary level and at higher level, if you learn how to bisect a line and bisect an angle, worst case scenario on the exam paper, bisect every line and bisect every angle. You may get some low partial credit for that, okay? So you're getting a couple of marks for something that you mightn't have known. That's really easy. You'll learn it in 10 minutes. Those at higher level do the same, but also for the proofs, you'll see for the formal theorems that we have to learn, they have a layout. They start off with, I suppose, the to prove part. We have a diagram, we have a construction, and we have the proof, okay? If you learn off the diagram for each one, and try to do some sort of construction, you may get some marks as well. So that covers you to get a couple of marks in a question that you might not be banking in. But please let me stand back and say, as a Leaving Cert teacher and as an examiner, you simply, unfortunately, have to cover everything. But we'll show you here at the end what topics are weighted more than others. But geometry, constructions and proofs, don't leave it till the end. Find a quiet time in 5th year or in 6th year, get it started. Even if your teacher isn't covering it yet, you will be ahead when that time comes and it will all stand to you. So you have full autonomy and full potential to grab that and go with it. Right, this next one is a nifty wee trick, and I have to credit my best friend who is also a maths teacher, Christina, for this one. Christina's from Mayo, and I can hear her scream this in her Mayo accent. If you don't know the answer, make it up. So let me explain this. We're saying play the game here, be strategic. So we know from exam paper questions that most question parts are standalone. They don't domino into one another. So for example, part A doesn't always go into part B, and you don't always need that answer for part C, but sometimes it does. So let's say you don't know how to do part A of a question, but you need that number in part B or later parts. What are we doing? If you don't know the answer, make it up. So let me show you what I mean by this as to how we can strategize in our exam to figure this out. So this should help you in a situation where, say, for example, you're looking at a question, I can't do the first part, but I can do most of the rest of it. So this is how this strategy would look. I'm not going to get into it, okay, but to summarize this question, we have two functions for populations at our higher level question here. We have an S and we have a K in it. And in part A there, it asks you to find S. Let's just say you can't figure out S, but you know how to do part B. You must do this. If you don't know the answer, make it up. Say S is 10. Don't know what S is, say S is 10, pick a number. What we do then is bring that value into the next part so that when we're using the function, instead of S here, I'm using 10e to the 0.1t times 10 to the power of 6. And then you'll go off and do your part B using that wrong answer from up above. So to rationalize this, in part B, you've done the correct thing because you knew how to do it, but you've used the wrong number. So what will happen here by doing this is you will get 0 marks in part A because you've done the wrong thing. You have a random number. That's not what it is. But because you've done the right thing in part B with that wrong number, you're not going to be penalized again. So the examiner may give you up to full credit here for that answer. You could get high partial or you might just get mid depending on the scales. But I hope it's clear here. If you don't know the answer to one part, bring it down into the other. The same applies for ordinary level. Let's say in this question, you can't do part 1, but you know how to do part B. Make up that the net income is €100,000 and use that number down in part B or in part 2, that you need the net income to complete that. So use your 100,000. Yes, you will get no marks whatsoever for the first part, but you can get up to full credit depending on the situation from the examiner for using that wrong answer. So this is particularly useful in those busy kind of geometry, trigonometry, and area and volume questions where we might not have a measurement and you had to find it. So if you don't know it, make it up. But you must be consistent in using it later on to get that credit. Finally then, last in our masterclass here is if you're studying Leaving Cert Maths, which you are all doing here, you need to know the big players in paper 1 and paper 2. So this is all in our blog. For Leaving Cert Ordinary Level, for Leaving Cert Higher Level, you can see the ones that are in bold and starred are the big players. Are there sometimes other big players? Of course there are. But if I was saying to myself, right, I have mocks coming up, I would have all of these covered in advance of that. Make sure you have your ground covered for paper 1, paper 2, either at higher or ordinary level. The other smaller topics are typically either short questions or they do appear in long questions as well. Like, look, we could expand the list, say for Leaving Cert Ordinary Level paper 1. I know sequences and series and differentiation comes up quite a lot, but it may not outweigh the other 3 up top. So I feel if you have all of these bases covered, you will pass. Okay, but what you need to do then is get working on the remainder to build that up. So look, this is your topic list. And I suppose if we start at the end, at the start, I told you that you need to start bluntly doing questions to study maths. These are the topics I need you to take note of. I need you to make a ranked list of worst to best and get working on them going on from here. So hopefully, folks, from these 10 tips, I hope you're going away with something, be it the notion to make a plan, be it some practice questions you're going to do, be it implementing my 2 20 to 30-minute short sessions a week and our big one. And finally, and ultimately, that doing questions is studying maths, and Studyclix with our boost, our quizzes, and our test yourself sections, we have it all there to help and support you. So folks, that's it from me in the masterclass side of things. They're the 10 things we need to do to succeed at Leaving Cert Maths. And I know we're going to open up now, and my colleague Amanda is going to jump on with me for any questions.
Thank you so much, Stephen. Fair play to you. That was a good length there. I think I even learned something myself, even though I'm so far from doing Leaving Cert Maths at this point. I picked up a few tricks as well. We've had a few lovely questions in from the guys in the chat. I'm just taking a quick look here. I think it was back when you were talking about the formulas in the logbooks and the ones that you need to learn off because they're not in the logbooks. And the question was about what is the best way to learn off a formula? Do you have any tips about how to memorize those formulas?
Yes. So I suppose, like, if I think about the confidence interval formula, say for a proportion, whether it's at higher level or at ordinary level, sit down, write it down, say it out loud first. Make sure you know how to say, for example, p hat plus or minus 1.96 square root. Chant it out. Say it to yourself 20 times. I know it sounds mad or a bit daft, but physically, orally say it. Then turn around, write it out. See if you can write it without looking at the sample. Write it out 10 times, write it out another 10 times. Come back and do that over 2 days. So say you're picking a week where you're doing your statistics. I'd be starting on that first day saying, right, I'm going to get this formula learned. Repeat on the second day, say it out loud, write it out. And then I suppose the muscle memory and the long-term memory there will help you. Like, you might have to refresh them come the Christmas exams, come the mocks, and come June, but the hard work is done. Okay, drill and practice, write them out, and also say them aloud. And I suppose even if you want to send yourself a voice note of them, if you've got a 10-minute walk, say it, put it on loop, speed it up, and it'll get through there. But unfortunately, it's not pleasant. There are a lot of them. You just have to repeat that for every single one. And maybe one last tale on that is the stories. I remember thinking, create a scenario with the letters in it, maybe create, not a role play, but a bit of a drama. Think of something and just create a story that you might remember.
Yeah, I think that applies to a lot of kind of study techniques as well. It's just having it kind of pass through your hand as many times as possible and generating that muscle memory is probably the biggest tip to memorizing anything, really. Just the repetitive kind of brain to hand maneuver. Some good stuff coming in here as well. This is a great one about just kind of exam anxiety and the nerves and kind of how to settle those nerves in order to logically approach your question. Any tips for that?
Yeah, so I suppose, like, I've experienced it myself. You sit down at a question, you say, my goodness, I've never seen anything like this before. And you just have that immediate kind of freeze. If you're in a position to come back to that one and you find one to get yourself eased into, go with that question first that you definitely know you can do. But you are going to have to face that question ultimately. I suppose standing back with that highlighting technique, they don't have any words in that question that don't need to be there. So you need to stand back and say, right, what are the filler words and what are the important ones? Like, I think of, say, differentiation. If I see the word maximize, I'm saying that's there for a reason. Okay, maximize dy dx equals 0. Or, for example, in our statistics example on the ordinary level question, it might say the mean. What does the mean mean? And you might even physically write out to find the mean, add them up and divide by the number of numbers. Start working with that. If you have a diagram, you might sketch it out, label what you have. And I suppose, particularly if you have a diagram, put an X on the side you're looking for. Okay, don't just repeat the diagram. Fill in all the numbers that might be in the passage, put an X on the side or a Y or whatever your favorite letter is, and just get started from there. But as I say, the words in the question very much are there for a reason. So say, what words can I ignore? What are the big ones?
Nice. And I enjoyed your tip about not just highlighting for the sake of it, just highlighting strategically. A classic question here as well, that age-old question of when is a good time to make that decision to switch levels if a student is feeling it's time to drop down to ordinary? What kind of conditions?
Absolutely. So look, I suppose I'll look at this through two lenses here, 5th year and 6th year, but I need you to stand back first and say, is math something I'm going to be doing going forward? Am I doing a maths related course in college? Am I going into STEM? If you're going into STEM, you typically may need some higher level maths. You don't always, but that would be my first kind of port of call to say, is that the requirement? For 5th years, now. And that's a bit blunt and that's a bit stark. We are, I suppose, a quarter of the way through 5th year. We've been on the algebra probably throughout the country. Most maths teachers dive into algebra. If you've not been hitting your 40, that's the threshold. We need 40 plus there for a confident pass. If you've not hit that on average in all of your tests by now, you need to either A, reconsider your revision plan and get going on that, or B, stand back and say, is this working or is this not? And this is the reality for the 5th year. You're a quarter of the way through the work of 5th year. you're 1/8 through the course of Leaving Cert. You're 12% the way there. So it's a harsh reality as well, because I think we haven't had to make that decision since second year or third year around levels. So be honest with yourself, but speak with your teacher. Those for sixth year, look, the earlier the better. I suppose your Christmas or November exams are your teller. Are you getting a confident pass? And on balance, from your summer exam last year to your November exams now, am I hitting 30? Now, for the sixth years, I'll often see a transformation of, if you're getting in the 30%, you can be okay. Okay. Not always. Sometimes it's a risk. It can be okay with the work. Okay. So in that 30%, you need to go with that. But stand back here, folks, and say, right, Leaving Cert's a game of chess. Am I jumping in for this just for the sake of 25 points? It's cliche, but the time it takes to pull a failing higher level grade up to a pass can certainly bump up other subjects. So don't do this to the detriment of your other subjects. I think of the 56 points for an 0-1 at ordinary level, and I think of the 71 points for a higher level pass, and I see 15 in the difference. And I'm saying to myself, right, I'm not saying a fail at higher level or a H6 at higher level translates to an 0-1, but you need to weigh that up. This is a game of chess for ye as well. And you need to say, right, can I devote the 2 half-an-hour sessions and the 1 long revision session a week to the maths, or what's my sixth year going to look like? So it's case dependent, but you do know now.
Perfect. Thank you, Stephen. We have another question here that relates specifically to worded questions and finding them particularly confusing. Any advice on these ones?
Yeah, and I suppose with these ones, like I'm going to say trigonometry, for example, can often have a big passage. They might have some sort of a 3D figure or a load of triangles, and it could be a boat on the sea looking up at a cliff edge, and there's all this information about the weather and things like that as well. When you're doing your structured revision, say you're working on your trigonometry, you're going to get exposed to various scenarios on that. And I suppose with your textbook, have a look, and this is where we often pass it. At the start of every chapter, there's a keywords box. And I think we, as Leaving Certs, we pass that. So stand back and say, right, trigonometry, perpendicular might be a word they'll use. Vertical is a word that they might use. And just even working through the exam papers on all of that same topic, you will start to come across them. So I suppose the exam day for the first time isn't the day to fully pull them out. You will begin that familiarity if you do that systematic revision of topic by topic. But do not overlook that keywords box at the start of every chapter, and if you can't find one, Google one. You will certainly find them, and it's just to be familiar with them.
Nice, very good, thank you. I think we've about time and conscious of the clock as well. We'll take one last question. General advice for a fifth year who at this point is aiming for that H1.
Okay, fifth year there, and I suppose the textbook has only so many questions. What I'd advise you to do is get practicing the harder questions. Okay, you don't need to really worry about the introductory questions or the questions at the beginning of the revision exercises. Try to get your hands on another textbook. So if you're using textbook X, go to a bookshop, buy textbook Y, practice more questions. There isn't often a point, there's no need to go ahead, okay, and say I'm going to start the next chapter myself, because you want to be working with your teacher and building that fully solid understanding on that topic as you go along in fifth year. So say right now your teacher might be working on logs. You've exhausted your textbook, get another one. Or what's lovely is our Studyclix quizzes are all exam style questions, and they're fully differentiated. We have the hard, the medium, that is the really, really challenging. I've made the majority of them. They reflect exam style. So work with them and push yourself. And for that fifth year, looking for that top grade, think about multiple ways of doing things. If you just take something, say, for example, adding and subtracting fractions, right? You might be able to do that in a breeze, but get researching. Is there another way to do it? Is there another way to approach it? Expose yourself to that. So you have that bit of work to do. Get another book, possibly, work with our quizzes, and think about the alternative methods.
Great. Thank you so much, Stephen. We will leave it there for tonight, folks. Thank you so much for your time and attention since 7 o'clock. And thanks so much to Stephen. Everything that Stephen talked about tonight can be rewatched. Of course, this has been recorded and will be available on YouTube afterwards to watch back, as well as the Studyclix website itself. Stephen has put a lot of what he's talked about tonight into a guide on Studyclix, and you will find this on the maths page within Studyclix. So you can take a look at the written version of all these tips as well. Again, thank you so much for your time and attention. We hope you found it useful, and big shout out to Stephen for all the great work as well. Have a good evening, everyone, and thanks for joining us. Bye-bye.
Take care.